This video explains the concept and implication of an omitted variable bias in a linear regression model. Simply speaking, an omitted variable bias of a linear regression model refers to omitting a regressor which contains information about y and which correlates with the non-omitted regressors. The OLS estimate of all slope coefficients of the non-omitted regressors will be biased. The bias does only vanish if the omitted regressor has a correlation of 0 with the non-omitted regressors. Now let's look at the math. Here's a simple example. Suppose the linear regression model in population reads as follows: y equals beta 0 plus x1 beta 1 plus x2 beta 2 plus epsilon y, and x2 is a plus b times x1 plus epsilon x2, and both epsilons here are white noise shocks. So you clearly see that x2 is a linear function of x1 plus some noise, and x1 and x2 are both useful for predicting y in a linear fashion. So let's rewrite the last two equations as one equation. You will get that y equals a constant c plus gamma times x1 plus epsilon tilde y. So it's a linear regression model in x1 only. And let's make sure the last equation coincides with the previous two. So c has to equal beta 0 plus a beta 2. Gamma has to equal beta 1 plus b times beta 2. And epsilon tilde y has to equal epsilon y plus beta 2 times epsilon x2. So if you now regress y on x1, so you are omitting x2, the OLS exogeneity assumption is still fulfilled. Yet the OLS estimate of gamma will not coincide with the population parameter beta 1. In fact, gamma will be larger than beta 1 for b times beta 2 being larger than 0, and gamma will be smaller than beta 1 for b times beta 2 being smaller than 0.